It's my pleasure to welcome Stefaan De Mey from European Space Agency, who will join us online and tell us about the new generation of space stations.
Thank you very much. I'm very pleased to get this opportunity to present actually what we will be doing in the future, in the near term, but also what we plan for the long term. And long term, I mean after 2030. I will try to share my screen. Right, I'll start talking already. So at the European Space Agency, we have a program for exploration, which is Terra Novae. We have 3 destinations: low Earth orbit, the Moon, and Mars. And our intention is to expand human presence in the solar system. For this, we have astronauts, and here you see a lineup of our astronauts who have been flying last year, Thomas Pesquet and Matthias Maurer. Currently, we have Samantha Cristoforetti on board the International Space Station, and Andreas Mogensen is our next in line. He will fly in 23 next year. This is our current class of astronauts, but we're already recruiting the next class, the class 22. And by the end of the year, we will recruit 4 to 6 new astronauts and also a pool of about 20 reserve astronauts that may fly in future. They fly to the International Space Station in low Earth orbit. In low Earth orbit, we want to stay there, therefore continuity. But we want to go further, and the ambition is to have the first European astronaut on the moon's surface by 2030. So that's a clear ambition set by the ESA Director General, with the vision, and that brings us to Mars, to have by the early 2040s Europeans on Mars. And then you see also a 4th box on the slide, inspiration, and that is something I will touch base on at the end of my presentation. It's about the question, how does it come that Europe has astronauts in space, but has not yet the capability of launching them ourselves? But let's start in low Earth orbit, 400 kilometers above the surface of Earth, so really not very far away. We are there in the International Space Station. We prepare exploration to the next destinations, Moon, Mars, in the International Space Station. But I would like to mention here as well that the space station is not the only low Earth orbit, low gravity facility. We have a lot of analog facilities on ground: sounding rockets, parabolic flight, drop towers, Antarctic missions, bed rest studies are some of the examples. The International Space Station is currently there, and we don't plan to give that up very soon. The operations are planned at least until 2030. The infrastructure has been built up over the past 20 years, and for the coming 10 years, 8 years if you wish, we're upgrading our facilities, and especially also the Columbus laboratory, with new computer systems, new payloads, and new instruments. We already contributed to the space station. This is the big window, cupola, is a European-built infrastructure. We have a lot of outfitting equipment, freezers, life support systems, air quality monitoring systems. We have a robotic arm, very recently launched, and that's the European robotic arm. And we also started commercialization. And that brings me to the post-ISS area. Once ISS will not be there, the plan is not to have a space agency-owned infrastructure anymore, like the International Space Station, but to allow industry to provide services in low Earth orbit to our needs. And to prepare industry for that, we already started a program with partnerships with industry. And currently we have 3 such partnerships on the International Space Station, where private companies are running a service, and anyone in Europe or in the world can go to that company and order a service to run experiments on the International Space Station without the need to pass through the agencies, fully commercial. And then for the long term, after 2030, once the space station is not any longer there, we would like to have grown that small capability currently into a fully end-to-end commercial service. Obviously, this is a very big endeavor for the commercial parties, and probably Europe will not be able to do that on its own. In the United States, there are already quite some actors building on commercial stations. So what we also envisage is that there will be a close cooperation internationally between those commercial companies. The next destination is the moon. Sometimes we call it the eighth continent, and the surface of the moon, you can compare it to the surface of Africa. And I always say we've never discovered the moon, explored the moon, and I don't say we didn't went there. Apollo missions have been there, but we never explored. There are only a handful of people that have visited a handful of places, very limited on such a big continent. If you imagine 5 people visiting 5 spots in Africa, you don't have seen Africa. So we have all reasons to go back there. And the clear ambition of Europe, as I said, is to have a European on the surface by the end of this decade. How will we do that? The first step is the Orion capsule, Artemis missions from NASA. This is a capsule that will be launched on the SLS rocket and will bring astronauts in orbit around the moon. And what is fantastic in this system for Europe is that this time, contrary to Apollo, we are part of this endeavor. The Orion capsule is propelled into space by a European service module, powered also with the European solar panels, a life support system, everything the astronauts need to survive on their trip to the moon. Now, the trip to the moon is one thing, orbiting the moon is another thing, and the Artemis 1 mission that is currently planned to be launched probably at the end of this month now, will do an uncrewed test flight to then have in 24 a crewed test flight, and then the system will be operational. And then we need a destination. The surface is the destination, but to get there on a sustainable and regular basis, we also plan to build a small space station around the moon. And we call that space station the gateway. It will be the gateway to the surface and possibly also to other destinations beyond the moon. And here again, fantastic for Europe is that we are fully part of this endeavor. More than 50% of the modules of that space station will be ESA or built by European companies. Because the first habitation module that will be launched, the American Halo module, actually is bought from a European company and actually built in Turin in Italy. ESA will contribute 2 modules, the International Habitation module, which is the biggest habitation module on that station, and also the Esprit module, and that's a module that has a refueling key, but also, for instance, a window, and that's a very interesting capability as well. We skip the animation and we go to post-2030. Going to the moon is one thing, to the surface is another thing, and our NASA colleagues in the Artemis program are already contracting SpaceX to bring the astronauts to the surface. But in this international campaign, Europe has also a vision to contribute, and our contribution we foresee is the Large Logistic Lander, EL3. We call it also the Argonaut. This is not a one-off mission, but a capability we plan to complement the Artemis missions for logistics, to serve the astronauts on the surface, obviously, to bring instruments, to bring infrastructure, energy. But at the same time, it's also a capability that allows Europe to take a leading role in self-standing European-led science missions. And on this visual here, you see a possible surface scenario where a lander is unloaded by the astronauts. You see a pressurized rover bringing the astronauts from the human landing site. And in the back, you see another lander who is doing some space resources processing, producing oxygen from lunar regolith. To explore the moon, to explore any destination, you need communication, you need navigation. And it happens that Europe is very strong in that area. So another option we have, and we're working on, is building a communication and navigation network around the moon. The first step is the Lunar Pathfinder. and that's a collaboration with, again, a private company in a partnership. And this Lunar Pathfinder is a satellite which will be launched in 2 years from now and will demonstrate and give the first communication services. And building on that, our plan, and that is something which will go to the Ministerial Council at the end of this year, we plan to have a constellation of communication and navigation satellites around the moon on a commercial basis to be provided to all international partners, commercial players traveling to the moon. And then that brings us to our last destination, Mars. Our vision for Mars is to continue what we are doing now, and that is the search for life. And at the same time, in our roadmap, we want to secure for Europe an independent access to the surface. We are already around Mars with our Praise-class orbiter. That's a satellite launched in 2016, scientific satellite, does excellent science, sniffing the atmosphere for molecules that can have an indication of life, taking very high resolution images of the surface, looking for water, and already published a lot of scientific results which are helping us preparing the next steps. This is part of the ExoMars mission, and the second part of that mission is the ExoMars Rosalind Franklin rover. Now, you all know that this rover was planned to be launched actually around this time on a Russian rocket, and this is of course not possible anymore. We stopped that cooperation. But this shows that Europe is missing something. We have a fantastic rover with the best scientific capabilities. We would be able, as a first, to drill 2 meters below the surface of Mars, with the only caveat that we're stuck on Earth because we're not capable of launching it. So that is something we want to avoid in the future. I will say a few words on that a bit later. What I can say is that we're working very hard to work out a proposal for our ESA member states to launch Rosalind Franklin on a different launcher with different partners. It's something we're working out now, and we will bring to the Ministerial Council for decision in November. It will mean that we will have to develop our own landing capability. That's very challenging, but it's something Europe needs to have, because otherwise we risk to end up in similar situations in the future again. While we're trying to have our Rosalind Franklin rover again on track, we're also working on the next real history-making science mission, and it's the NASA ESA Mars Sample Return Campaign. Samples are currently collected by NASA, and to bring them back, we're building various systems, and ESA is contributing 2 elements, a sample transfer arm and the Earth Return Orbiter. The sample transfer arm is a 2.5 meter long robotic arm. It will land on Mars to retrieve the sample tubes that the NASA Perseverance rover is currently collecting from the surface. So we will identify, pick up and transfer the tubes in the first rocket built by NASA to be fired off another planet. And that rocket from NASA will bring it from the Mars surface into Mars orbit. It's kind of football size sample container. You see it on this image. And here you see also the Earth Return Orbiter, who will go hundreds of kilometers from Earth, searching for that little object, sniff it up, and bring it back to Earth. This satellite is actually the biggest ever satellite going to Mars, and as a first, also the first one returning to Earth. And you see it has a very big solar panels, because it has 42 kilowatts needed for the thrusters bringing it back. And the way back is 4 days with 4 electric thrusters. The end goal is to fly to Mars with humans. Obviously, that's not for tomorrow. It's also not for 2030. But our aim now we're working against is the early 2040s. And obviously, that's a very big endeavor, which Europe will not do alone. We'll do it in partnership, like we have the partnership on the Artemis missions. But we have to look for a European contribution that makes sense, that is visible, that is meaningful, and of interest to us. And currently, what we envisage building on our past experience with the shuttle flight, with Columbus Space Lab before that, with the gateway, all the habitation modules Europe is building, what we envisage is to build the Mars Transit Habitation Module. That is the module where the astronauts will be traveling in from Earth to Mars. And in the overall Mars surface scenario, we would then bring the astronauts to the Mars orbit, and then NASA will take them from Mars orbit to the surface. And that brings me to what I mentioned at the very start of my presentation. In all these exploration scenarios, Europe is lacking something, lacking autonomy to bring their own astronauts into orbit. If you would do a search on the internet on astronaut seats, you only have three options: the Crew Dragon, Orion, and very soon also the Starliner from Boeing. But why does Europe doesn't have it? Because imagine launching European astronauts on a European rocket from a European launch pad. That's one thing. And is it because we're not able? That's not true. European industry across Europe has been involved in space exploration for 20 years and has built the capabilities. It's just a matter of political will and opportunity to do it. We have the heritage. We have Ariane, we have the Vega rockets, we have had Space Lab, ATV, ISS, Columbus. We have our astronauts. We have ESA programs in space transportation. Space Rider will be flying very soon. We will have a new launcher, Ariane 6, Vega 6. We have Boost program, Prometheus. And then we have Terra Nova, our exploration program. We have the European service modules. We're building the gateway. We will have new astronauts, post-ISS LEO platforms. We have all elements to build on a new European project, which we call the Inspirator. And currently, this is not decided. This is a proposal to look into. And we're very fortunate that at the end of, no, in February this year, it was a European Space Summit led by President Macron from France, who have looked into this question, and they ordered a high-level advisory group to look into this and to report back at the end of 2023 with their conclusions. So now at ESA, we're supporting this high-level advisory group to look into this question and to come with a proposal or a recommendation at the end of next year. So that's something we're really looking forward to work on, and hopefully we will be able to come with a very good proposal to the ministers so that they can consider it and take a decision for Europe. Because we think that exploration, I didn't put any slides on that, but exploration, it's not a nice to have. In the first place, exploration requires developing technologies in robotics, and obviously I don't need to explain robotics to the audience here, which are extremely relevant also for terrestrial applications. The technologies to survive in space, circular systems, recycling, are more than ever important on our planet as well. Energy solutions, they are more than ever important for citizens and for countries. And on top of all this, the inspiration and the outlook that exploration gives to this and the next generation, to give them a yes, we can mentality, and to have a bright outlook to the future, this is extremely important. And that's why we explore. And with this message, I would like to end my intervention here. Thank you very much.